Very good morning to all of you. My name is Dr. Deepak Paliwal, and in my previous lecture, I discussed about time series analysis. What is a time series, and what are the various patterns that you can see in time series when you represent a time series in an x and y axis. Now, today we are interested in knowing what is autocorrelation and correlogram. Okay, so these are the tools which are helpful in identifying the patterns of data set, and we will understand today what is autocorrelation with a numerical data with an example. Okay, so before coming on the numerical example, first of all, let us see the significance of this word autocorrelation. Here auto correlation means self correlation. Okay, so because we have single data set and we have to use this data set for correlation. You know very well that whenever we have to calculate correlation, that means we must have x data and y data, then we correlate those x and y data. That was the simple correlation that we know, but here we are doing the auto correlation. That means we have only single set of data and we are utilizing this single set of data for finding out the correlation. So that is auto correlation. So now let us see in this example. Here we have the data set. You can see 97, 110, 121, 119. So these are the data set and these are the serial number. So if you connect this data set with my previous example, that is if there is an industry which is producing some product and you as an engineer, you are finding out in January 97 products are manufactured in through that line, in February 110, in March 121. So these 1 2 3 4 5, these are all the serial number and representing a particular time period. And this is it varies. It depends upon you how you are doing the times, how you are collecting the time series. Are you collecting it according to month or according to week, according to day, whatever. Okay, so the important thing is the collection of data. So this is what we have collected. So 9700, and this is the data set. So once you have the data set, then first of all what we have to do, we have to find out the mean of this data set. So if you calculate the mean of this data set, that means you have to sum these values. So when you sum these values, you will get 1075, and for calculating mean, this is 1075 upon 10, because we have total 10 data, okay, in this data set. So we are calculating mean. That means 1075 divided by 10 equal to 107.5. so this 107.5 is the x bar. Now next what we have to do, we have to generate a new data set. Okay, this is the initial data set. Now we are generating new form of data set, and this new form of data set is nothing but this is x minus x bar. X bar is recently we have calculated, which is 107.5. Here what we have to do, we have to subtract x. So x is changing. In this case x is 97, in this case x is 110. Similarly here 121 is the x, but in all this data set x bar is common, which is 107.5. so here 97 minus 107.5, so this is minus 10.50. Similarly here 110 minus 107.5, so this is minus 2.50. so likewise you can get the new data set, okay, in the second step, which is nothing but x minus x bar. So once you get these values, what we have to do, we have to find out the variance. What is variance? Each value, whatever value you are getting, you square that value and square all these values and then make a total of that. Okay, as it is clearly you can see in this formula, this is x minus x bar whole square. Okay, so x minus x bar is minus 10.5. so minus 10.5 square plus 2.50 square plus 13.50 square plus 9.5 square plus 28.5 square. So you square all these values and sum them and divide it by n minus 1, where n is same, this 10. So you do this, you will get a new value. This is 459.2. 459.2. Okay, so this is the variance. Next, what you have to do here, one important thing is autocorrelation at x equal to 1. So sorry, k equal to 1. So k equal to 1 is the level where we are doing the correlation. So let us understand what is the physical significance of k equal to 1. K equal to 1 means you skip one value, the first value of time series. The first value of time series is 97. Okay, the first value is 97. So next value is 110. So this is the first data. 121, second data. 117, 117. So this data set is created over here. You skipped this 97. Okay, so this is the new data set. And here, because we have excluded this 97, the first data, so these data are jumped. Okay, so this is the new data set, which is x considering k equal to 1. Now based on this, you are calculating x minus x bar. Here x is nothing but k equal to 1. So in this case, this is 110 minus 107.5. So this is 2.5. Likewise here 121 minus 107.5. So you have to do this exercise for all these data sets. This is x, k minus 1 minus x bar. Okay, 2.5, 13.5, 9.5, minus 28.5, 32.5. So likewise you can get all these data. Then what you have to do, you have to find out this, that is x minus x bar multiplied by xk minus 1 minus x bar. So what is x minus x bar? Minus 10.50, and you are multiplying it with 2.5. okay, so multiply this value and this value. Okay, so when you multiply both this value, you will get 26.25. Similarly, you multiply this line and this line. You are continuously multiplying these values and you are getting these values. Next thing is, once you get all the data, you sum it and divide it by 10. So this will give you minus 329.37. So here you can get the value of correlation, and this is nothing but the ratio of minus 329.37 divided by 459.2. So in our case, when we have considered k equal to 1, when k is equals to 1, autocorrelation is minus 0.72. okay, so this is how mathematically we can calculate the correlation. Similarly, autocorrelation can be considered for k equal to 2. okay, and how we will calculate for k equal to 2? If we calculate it for k equal to 2, that means you have to skip 97 and 110. Two values you have to skip. That means 121 will come here. Okay, and the complete data set will be shifted up. This 110 will be gone from here. Okay, and you will find one dash here and one dash here. Similarly, you will do the complete exercise again and you will get one more value of autocorrelation, and that will be another numerical value. So likewise you can calculate autocorrelation, right? So once you get the autocorrelation, by repeating these steps again and again, you can make a table. So this is, let us say k is 0, 1, 2, 3, 4. okay, when k value is this, for each k autocorrelation. Now here, if k equal to 0, the autocorrelation value will be 1 only. okay, so this you can clearly see here. If k is equals to 0, that means there is no value you are going to skip. The same line will be repeated over here, and when the same line will be repeated over here, these values and these values will be same, and if they are same, then definitely this is the multiplication of this and this value, and when you are calculating variance, the same cheese is repeating over here. So this is x minus x bar square. Here also it will become x minus x bar square, but here it is 10 minus 1 and this is 10, and when you solve it you will get the value 1. Okay, so this value will be close to 1. So similarly you will do the calculation for 2, 3, 4, and you can get these many correlation based upon whatever assumption you are taking. So thank you very much. So in this lecture we have discussed about autocorrelation, how it can be calculated. We have taken one numerical example, and in the next lecture we will try to understand that how we can make correlogram and how correlogram can be used to identify the pattern of a data set. Thank you very much.